Some people are not writing anything. Goodness. Right. So F stands for find. W stands for when. G stands for given. And to find any, not any, to find or to figure out the differentiation implicitly, we have to find equation. Had a moment there. And there's actually a way to figure out what these basically are. You can either find the word find within the word or within the word problem. You could also find what. It could say how many something. It could say determine. The bottom line is anything that is similar to these word problems with find, what, how, and determine is going to tell us the F piece. Now, right now, it doesn't mean anything because we don't have an example. When, you'll literally see the word when within the word problem. And there will always be a given rate of something. Always, always. An equation is something typically I'm going to give to you unless it's simple. For example, a simple equation that I'm not going to give to you is going to be area of a circle is what?
Pi r squared.
Pi r squared. Those I want you to know. What is the area of a square?
Base times height.
Okay, base times height, but then in a square, base and height are all both the same.
Oh, side squared.
Side squared. Okay, so we'll get familiarized with them, so don't worry about trying to figure out which ones we have to know. 3 is the main important thing in my opinion. So far, we have been finding the differentiation with respect to t, or x, I mean, for all the word problem. It's going to be derivative of something. That could be volume, area, circumference, with respect to time. Because all the word problems are time related. So let's actually use the rule above on number 1. So Milo, read number 1.
Everything comes into a spherical balloon at a rate of 4 pi per minute. Determine how the radius is changing when the radius is.
Okay, let's all write out Fuigi on the side. And if you have another method and you don't want to write this out every single time, use it. But this is the best method for me. So find or determine or what or how do I see that word right here? Determine. That's going to be my F piece. What are we changing? What is changing? So we are going to write out dr as in radius, dt. And again, all word problems are over dt. Now let's look for the W, the Fuigi W. Do I see when anywhere? When. So here's our when. What is given to us? The radius is 18 inches. And yes, do write the units. And then G is going to be any rate. Do I see rate of anywhere?
Yes.
That is our given rate. Here's our G. So our given rate is going to be, it says, the air is being pumped into a spherical balloon. When I'm putting something in a three-dimensional object, that's going to be representing what?
Volume.
Volume. So dV over dt. And that's going to be 4 pi feet cubed per minute. Now, if you were going, what if I didn't know that it was volume? Not a problem. When something is cubed, we know that's automatically volume. So your unit is going to tell you, is it area, is it a length, or is it a volume? And then our last one is the equation. Is my equation given right here? Yep. So we have our volume equation is equal to 4/3 pi r cubed. So now that we have all the parts of Fuigi, we can actually solve for them. So any equation that is given is what we are going to differentiate. So let's write that off to the side. Volume is 4/3 pi r cubed. And our rule still stands. Derivative, not with respect to x and more problems, but it's going to be with respect to t. So again, we're doing more implicit differentiation practice, in case you were like, well, I didn't do the homework. 1v, what is the derivative of 1v? 1, and again, just like the y, we're going to say dv over dt. Every single time. The next one, keep in mind a pi is a number. So our rule says we take our power and multiply by the coefficient. But when I do with a 3, cancel this one out. So let's write out 4 pi, r not cubed anymore, but square. And again, dr over dt. And at this point, let's go ahead and see what is given to us. And circle the item so that I am as well. So dv over dt. Don't we know that piece is given to be 4 pi? Does everyone see that? What else is given to us that we know? Now, should I leave it as 18 inches? Because in the end, what do we want? Feet. So I'm going to go ahead and write this as our feet. There's 12 inches in a foot, so 18 is 1.5 feet. So let's go ahead and circle that with the same color just for teaching purpose. And let's plug everybody in that I know. The 1 is understood, so I'm just going to write out 4 pi is equal to 4 pi. The radius is 1.5 squared times dr over dt. Now the only variable remaining must be what we are looking for. It says to find dr over dt. Is that by itself already? That's always good, the fact that that is in terms of its own variable, not a number. So now, let's do our basic math. What's on the left and the right that I can cross out? I'm going to knock that one out. And for teaching purpose, I'm going to write this piece out. When everything's knocked out, we have understood 1. Oh, equal to, I mean. And let's write 1/5 as a fraction, because to me, I think fraction might be cleaner. You might disagree, and that's okay. Isn't 3 over 2 all squared 9/4? And to solve for dr over dt by itself, I need to multiply by the reciprocal, which is 4 over 9. Dr over dt. And I should really rewrite this in a better way. Dr over dt is equal to 4/9. And we were looking at feet per minute. So if it doesn't bother you that you went from right to left, you can leave it as the first portion, but I'm going to put it as the right side. All right, so we've got it all done. So the whole implicit differentiation was to get you guys to the related rates. And that was it. Hudson.
Remind me how you got 2, 4, 5.
I can't hear you.
Remind me how you got 2, like 4, 5.
2, 4, 5. Where's 2, 4, 5?
Where's that on the right?
How we got this?
Or no, like how you had a 4 pi on either side.
2,
Oh.
2, 4, 5.
D,
Yeah.
I see. 2 sets of 4, 4, 5.
Yeah,
Okay.
that would've been a better way.
dv over dt is given as 4 pi. And then from the differentiation of the equation was 4 pi.
You switched them.
We didn't switch them.
I'm like, you took out the DV over DT.
Yes, I replaced them. All right, let's move on to number 2. So on number 2, I want you to decide on with your neighbor. What part is my F? What part is my W, G, and E? And if you mess up, that's okay, because I'm going to go over it with you. Talk to your neighbor. I wish they would turn the volume down. Can't. So jammed. I'm going to go over it. Just wait for me. 10 seconds. All right. What word is telling us where the fine is going to start? The what? Is the rate of change of the area. So that means the area, I'm going to denote that with a capital A, over dt. Now, there's always a word when. Do we see it? When? When the side is 5 centimeters in length, so S is equal to 5 centimeters. And try to differentiate your S to 5s because they typically look the same. At least for mine it does. Now there's a given rate. Is there a rate of? Our rate of, and this rate is, the side is increasing. So we have ds over dt. So it's at 0.4 centimeters per second. And the equation on this one, not given. How do we find the area of a square? Side squared. The simple ones like that, I'm not going to give you. So let's go ahead and rewrite out that equation off to the side and figure out what we need. So we have the area is equal to side squared. And let's go ahead and differentiate derivative of this function with respect to x or t. T? I know, it's called habit. Okay, what is the derivative of 1a? 1. Then we have dA over dt. Oh, no, that's not d. What's the derivative of side squared? 2s. And good luck with writing the s's, not looking like a 5. And then I'm going to start circling what I see on the left and the right to compare. My side is what number? 5. What else do I know? ds over dt. That's 0.4. And what's nice is our actual find, isn't that already by itself on the left right now? Because 1 times that is that cell. So let's go ahead and plug it in. dA over dt is equal to 2 times the side of 5 given. And the rate of the side was 0.4. So we know 2 times 5 is 10, and 0.4 of 10 is how many? Oh no, just 4. And the area is denoted with the squared per second. There we have it. Okay, let's go on to number 3. And again, with the partner, decide on what's going to go on your Fuigi to the left. Talk to your neighbor. Talk to your neighbor. Look at my color, so pretty. All right. What word is going to help us with the word find? When? Do I see it? How about this? How fast is the area? So we know dA over dt. And then let's go look for the word when. Here's our when. And on when it says, we know circumference is how many? 10 pi inches. Make sure you're writing. And there's always a rate of. That's always given. And that is the rate of the circumference. So we should write out dc over dt. 2 pi over 5 inches per minute. Oh, dang it. I'm not going to have enough room for this. And then the equation. How many equations are we involving here? There's an area that we have to find, and there's also what? Circumference. So let's write out both of them. What's our circumference of area of a circle? 2 pi r. And area is pi r squared. So here's a fun fact. As our dimension goes lower, it's a derivative. So watch this. What is a derivative of pi r squared? 2 pi r. Is circumference 1 less dimension than the area? Yes, it is. Okay, so that's just a little clever fact. So what I want you guys to do for this one, since we have 2 equations, write out both of them, separated by like a dividing line like mine. Because sometimes when given 2 equations, you might need to derive both, or you might have to derive one of them. Let's go with both on this one. So here I go. Let's find the derivative with respect to t at all times in the word problem. Right, Xavier? without your phone. Our derivative of 1c is 1, dc over dt. And our derivative of 2 pi r, and remember that 2 pi is our number, 2 pi dr over dt. And let's start circling the pieces that we already know. Do I know dc over dt? So I'm going to plug in 2 pi over 5. 2 pi. Do I know dr over dt? Maybe that's our variable. All right, so let's go ahead and cross off what is the same on the left and the right. They both have 2 pi's. So that means dr over dt is equal to the understood one that's pretty much nothing on the top over 5. Let's see how that's going to relate on the next equation. So let's go ahead and derive this with respect to t. What is the derivative of 1a? 1a is dA over dt. And yeah, you don't have to write the 1 down. It's understood. And our derivative of pi r squared is 2 pi r. And that's dr over dt. So then you might think, why do we find dr over dt? Because in the end, we needed it. So let's go ahead and circle the pieces that we needed. The dr over dt that we just found. What else do I know? Could I find the radius by plugging it in here? Do I know my circumference? 10 pi is equal to 2 pi r. So who must be my radius? What's 10 divided by 2? 5 it is. So let's start plugging them in. dA over dt. That is our final goal. So it's good that is already by itself. 2 pi times a 5 times 1/5. Which piece of that equation are we going to eliminate? The 5 and 1/5. So that means our final answer is dA over dt is equal to, is it 10? No, 2. 2 pi, and our unit is the area, it's squared, inches squared per minute. All right, we're on the last one. Are you ready for the last one? Okay, for number 4, let's find Fuigi together for time's sake. So Fuigi. Xavier, let's read. The radius.
The radius of a spherical balloon is increasing at a constant rate of 5 millimeters per second. What is the rate of increase of the surface area of the balloon at the instant when the volume is 36 pi cubic millimeters?
All right, the rate of is our given rate. That's all right, G. And our given rate is talking about the radius. So we have dr over dt is equal to 5 millimeters per second. Are we good with that piece, the given? Okay, the next one. What is our find piece? We want to figure out what the rate of the surface area is. So dA, as in the area, over dt. If you're looking at surface area, thinking of SA, you can plug that in, but I just want one letter. And again, that's my preference. And then our when is right here. The volume is how many, it says? 36 pi. And our units for this one will be millimeters cubed. Now, the equation is not given to us. Now, any idea what the equation is going to be for the sphere? How many do we even need? There's a volume involved and area. So let's go ahead and write out the volume. So our volume is equal to 4/3 pi r cubed. Then that means my surface area is one dimension lower. And let's kind of use the logic from the previous one. The derivative of 4/3 pi r cubed. The 3's are going to cancel. That is going to give us 4 pi r squared. And yes, that is the area of a sphere. Okay, so if it helps you to remember them by knowing one formula, go for it. All right, but then which one are we going to derive according to what we're looking for? Probably the area. Okay, let's go ahead and write that out. We might have to derive the volume. We never know. So let's write area is equal to 4 pi r squared. And let's derive this and see if I have all the pieces. Derivative of this function with respect to t. So we have 1 times dA over dt. Is everyone good with that? The second piece. When I multiply the coefficient and the power, what do I get? A pi r dr over dt. So let's see if we have all the pieces right now. We have dr over dt is 5. What else do I, or should I have? For the radius, can I plug this volume in here and find this radius? And I'm going to use the room on the bottom since I'm going to ignore number 5. So our volume is 36 pi. It's 4/3 pi r cubed. What can I knock out that is on the left and the right? Pi's, very good. And then we are going to multiply by the reciprocal. When I multiply that by this reciprocal, any idea what that's going to give us? Let's actually write it out. 3 over 4. 3 over 4. Would that cancel the right side out though? Yeah? So we have r cubed. So here's an easy way to go about this problem. Instead of doing 36 times 3, why not do 36 times 4? I mean, divided by 4. How many is 36 divided by 4? 36 divided by 4 is 9. 9 times 3 is 27. So what must be our r? 3. So now let's plug that into our equation. dA over dt is equal to 8 times a pi times 3, and the rate that was given was 5. And that's going to give us, someone go ahead and multiply that out. I would do 5 times 8 first, and then multiply by 3. 120 pi. So we have millimeters squared per second.